Okay, on this problem it says simplify the equation and find any x-intercepts, vertical asymptotes, and horizontal asymptotes. Okay, well this is the equation right here, and it's going to need simplified. So what we have to do is start factoring it. And let's see, out of the numerator here, an x factors out, and we'd be left with x times x minus 4. The denominator does not factor. This x squared plus 4x minus 21 factors into x plus 7 times x minus 3. And the x cubed minus 16x, well, an x factors out of that, leaving you with x squared minus 16, which is the difference of two squares, which factors into x plus 4x minus 4. Now, if you have trouble factoring trinomials like this one, x squared plus 4x minus 21, you can do that on the poly sheet. On the right-hand side of it, it has a place for factoring polynomials. Like, for example, that expression, x squared plus 4x minus 21, it would be, I think that's a minus 21 was right there. And this is what it factors into. So it was x squared plus 4x minus 21, and that factors into x plus 7, x minus 3. And that's what we actually had there, x plus 7, x minus 3. Once you factor everything, then you just cancel out like terms, like the x plus 7 with the x plus 7, the x minus 4 with the x minus 4, the x with the x, and you're left with x minus 3 over x plus 4. Now at this point, this equation has an x-intercept at 3, 0 because you set the numerator equal 0, has a vertical asymptote at -4 because you set the denominator equal to 0 to find your vertical asymptote. It also has a horizontal asymptote at y equals 1 because you look at the powers, the numerators to the first power and the denominators to the first power, and if they're both to the first power, you just look at your leading coefficients, which are 1, and 1 over 1 is 1. So that's what the horizontal asymptote is. Now these terms that we canceled out here would be undefined points. So at x equals 4, since we crossed out a x minus 4 on both the numerator and denominator, that's called an undefined point. Same way with the x plus 7. Where does x plus 7 equal 0? Well, at -7. So at -7, it's an undefined point. And same way with x equals 0 because we canceled out an x on both sides, numerator and denominator. So if you cross something out on the numerator and denominator, if it divides to 0 and there is no more of those terms around, like the x minus 4 and x minus 4 canceled out and there's no more x minus 4s left, then that point is an undefined point. Okay, let's go to this one. It says simplify the equation and find any x-intercepts, vertical asymptotes, and horizontal asymptotes. Again, it's a messy thing that we need to factor. Now, if you're dividing in here, then what you'll need to do is reciprocate this second fraction and then factor it. So reciprocate it, change the sign to multiplication and factor. So the x minus 4, this trinomial factors into the x minus 4x plus 2. This trinomial factors into this, and this trinomial factors into this. Start crossing off like terms, the x minus 5s, the x minus 4s, the x plus 2. So the 5 at x equals 5, x equals -2, and x equals, well, not the x equals 4, because there's an extra one here. But x equals 5 and x equals -2 would be undefined points. What do we have left? Well, we have 1 over x minus 4. So therefore, this function has no x-intercepts because there's no variable left on the numerator. It has a vertical asymptote at x equals 4. Even though we crossed them both off, there was one extra. So it does have a vertical asymptote at x equals 4, and it has a horizontal asymptote at y equals 0 because the power of the denominator is greater than the power of the numerator. Now on this function, we're just solving this equation. So to solve an equation, you multiply by the common denominator if there's a fraction. The common denominator is all this stuff. And then we say, well, what is extra in the common denominator that's not in this denominator? Well, the 2 and the x minus 3, and that 2 and the x minus 3 has to get multiplied times this 2 right here, okay? And then next, we say, what's extra in this common denominator that's not in this denominator? Well, the 2 and the x plus 2, and the 2 and the x plus 2 would have to be multiplied times this 8. And then what's extra here that's not in here? Well, an x minus 3, and the x minus 3 needs to be multiplied times the 1. And then that eliminates your denominator, and it just gives you a linear equation to solve. And you got to make sure that solution doesn't make the denominator equal to 0. And it doesn't, so that's actually the solution. So let's go ahead. Well, one last one here. Again, same type of thing, just a very messy equation here. You'd have to simplify all these denominators, factor them, And when you factor them, you have to get the common denominator, and this one's very messy here. The common denominator, we would need a 2x plus 1 squared because that's the highest power 2x plus 1 in the denominator. We needed one of these 2x minus 1s, and the common denominator between 3 and 5 is 15. So that's the common denominator. Then each one of these terms on the top needs to be multiplied by whatever is not in the common denominator in each of their denominators. So what's not in this denominator? That's in this common denominator, a 3 and a 2x plus 1. So a 3 and a 2x plus 1 needs multiplied by the 2x. And what's not in this denominator that's in this common denominator? Well, a 15, a 2x plus 1, and that would and a 2x minus 1, all those. So this is a very messy problem, and you'd have to use Excel then to finish it at this point. So we'll stop at this one, and we'll pick it up after that on the next video.